It will be extremely helpful for you if you can remember anytime you see a negative under the square root sign, the answer is I, and anytime you see I squared, it's the same thing as -1, you will be in great shape. So let's simplify these square roots. The first thing I'm going to do is rewrite the 3 with a multiplication sign because that 3 is just being multiplied out front. The square root of -16 is imaginary, but the square root of 16 is 4. And since it's imaginary, we'll put an I. And 3 times 4 is 12. So the answer here is 12I. Over here, we have 2 times the square root of -25. So I know the square root of 25 is 5, and since that negative's underneath there, it will also have an I, and 2 times 5 is 10I. When we look at C, I have a -1 out front, so I'll write that. And 75 is not a perfect square. If I do the factor tree way, I could break that into 3 times 25. 25 breaks down into 5 times 5. I have a pair of 5s that will come out of jail. The 3 will stay in jail, and we can't forget that we had that negative sign underneath the square root sign. Rather than put the I at the end, we put it right next to the 5. So the last step is to multiply -1 times 5, which is -5I times the square root of 3. Lastly, in D, we save that -1/3 for out front until the end. 63 is not a perfect square, but we can break it into, let's say, 3 times 21. 3 is prime. 21 we can break into 3 times 7. A pair of 3's comes out. That negative is underneath the square root sign, so the I will come out. And that 7 is left underneath the radical sign. Last step is to multiply -1/3 times 3, and that turns out to be -1, or just -I times the square root of 7. A complex number has 2 parts. It can be written in the form A plus BI, where A is the real part and B is the imaginary part. So if we had to set 2 complex numbers equal to each other, the real parts would equal the real parts and the imaginary parts would equal the imaginary parts. So for example, if we had A plus BI equals C plus DI, the 2 real parts, the A and the C, would be set equal to each other. And the 2 imaginary parts, the plus B and the plus D, would be set equal to each other. I have the I's there, but you really don't need to use them, so when you write it, you can just write B equals D, or whatever numbers are in those spots. So when we look at example 3A, the 3x is the real part, and the 6 is the real part. So that equal sign's in the middle. All we need to do is write down 3x equals 6 and solve it for x. We will get 2. Next, I'll solve for the imaginary parts. So I have -5. I'm going to set it equal to everything that's in front of this I, the -10y. To solve this for y, the -10 and the y are multiplied, so to divide by -10 on both sides will leave us with y equals positive 1/2. Same thing will happen in example B. We will take the real parts, -4x, set it equal to the real part on the other side of the equal sign, which is just 12. When we divide both sides by -4, we come out with x equals -3. Now for the imaginary parts. We take the -7 that's in front of the I, and we take the -49y. -49 and y are multiplied together, so to undo that, we'll divide by -49 and divide by -49. And when we reduce that, it comes out to positive 1 over 7. Finding a complex conjugate is not as complicated as it sounds. The first thing you have to make sure is that your number is in the complex form a plus bi, where a is first and the bi is second. If it's not in that order, you have to flip it around so it is in that order. The complex conjugate of something in that a plus bi form is simply a minus bi. So the only thing we're doing here is we're flipping that middle sign. If we started with a minus bi, then the complex conjugate would be a plus bi. So that's all we have to do is flip the sign in the middle. When we look at example A, I noticed that that imaginary part is first and the real part second. So I'm going to take the real part, the negative 15, and write that first. Then I'll write the imaginary part, the positive 2i, after it. So now it's in the correct form, and now to find our answer, all we need to do is rewrite it with that sign flipped. So the answer for the complex conjugate is negative 15 minus 2i. When I look at B, there is no real part in sight. If we did have a real part, it'd be 0. But all we need to do is flip that sign in the middle, and we will come out with positive 4i. When I look at C, it looks like we have the real part first and the imaginary part second. So all we need to do, there's the R, is flip that sign in the middle. The negative 10 stays, that sign becomes a minus, and the 2i stays. Last but not least, the real part's first, the imaginary part's second. All we need to do is flip that sign, so the answer here is negative 20 plus 3i. Just a few homework hints for you. On number 11, negative 4 is a real part. On the other side of the equal sign, the negative 12x is a real part, as well as the plus 8. So when you go to set up your real equation part, it'll be negative 4, then the equals, the negative 12x, and the plus 8. That's what you're going to solve for x for the real part. The imaginary part, you'll have just y equals, and in front of that I would just be a negative 1. So basically that's your answer for the y. And if you solve that blue equation, you'll get the answer for x. When you look at the complex conjugate ones down here, you might wonder if you need to simplify that. You do not. The square root of 5 is as low as that one goes. Same thing over here. You might look at this imaginary part and wonder if you need to simplify it. You do not, because the square root of 2 is already as low as that can go. Good luck.